Hello my dear friends and welcome to our today's class. It's our 9th lesson on the 5th topic of Form 3 work, which is called Current Electricity 2. As usual, let me commence by giving you the quote of the day, which states that there are two ways of spreading light. One is to be the candle that produces light, and two is to be the mirror that reflects the light to others. We shall discuss that quote at the end of our class today. So today we are looking at further examples involving current electricity too. So let's deal with our first example, which reads that 4 resistors are connected to a 6-volt supply as shown in this diagram. So we are required to calculate the current through the 13 ohm resistor. So again, the key points that you need to note: for any series connection, I total is equals to I1 is equals to I2, V total is equals to V1 plus V2, R total is equals to R1 plus R2, and so on and so forth. Then for any parallel connection of resistors, total current is equals to the sum of the currents, that is I1 plus I2. Then total voltage entering a junction is equals to the voltage drop across any component connected along that junction. Then the reciprocal of effective or total resistance is equals to the sum of the reciprocals of effective resistances. Then from Ohm's law, we know that voltage is equals to IR. So part A, they want us to calculate the current through the 13 ohm resistor. Now remember, our 13 ohm resistor is here. So the first thing that we're going to do, we'll group the resistors that are having the same current flowing through. So remember, the source of current is our source of power supply, that is the 6 volts. So when the current gets from this particular point, it moves up to the first junction, that is at point A. When the current gets to point A, it is divided into two. One of the current flows to the 5 ohm resistor, then the other current proceeds to the other resistors. So because the current that proceeds to the other resistors, the same current flows through the 13 ohm resistor, it also flows through the 3 ohm resistor, and it also flows through the 6 ohm resistor. So that one simply means you will combine, first of all, these resistors that are having the same current flowing through it before we join it with the other 5 ohm resistor. So the thing that guides you is actually the current, the flow of current. So from here, the current gets to the first junction here. Remember, the large bar represents the positive terminal, and we say that the current will always flow from the positive terminal of a cell or a battery towards the negative terminal. So because this is our positive terminal, the current flows up to point A. At this particular point, it is divided into two. So one of the current flows through the 5 ohm resistor. The rest of the current flows through the 13, the 3, and the 6 ohm resistor. So let's combine the 13, 3, and 6 ohm resistor because the same current is flowing through them. So we'll start by combining the 3 and the 6 ohm resistor. So of course 3 and 6 are connected across each other, so that is parallel connection. So we say that for any parallel connection, 1 over R total is equals to 1 over R1 plus 1 over R2. Therefore, because that is parallel connection, 1 over resistance through the 3 and the 6 ohm resistor. So we want to combine these ones that are in parallel first. So the 3 and the 6 ohm resistor. Remember, you cannot combine 5 ohm, 3 ohm, and 6 ohm simply because the current that is flowing through 5 ohm is different with the current that is flowing through the 13, 3, and 6 ohm resistor. So the reason why we are combining 3 and 6 without including the 5 ohm resistor is because a different current flows through the 5 ohm resistor, because when the current gets to this junction A, it is divided into two. One current flows through the 5 ohm resistor, while the remaining current flows through all these resistors, that is the 13, 3, and 6. So we'll combine 3 and 6 because the same current flows through them. So 1 over R through 3 and 6 ohm resistor is equals to 1 over R through the 3 plus 1 over R through the 6 ohm resistor, which is equals to 1 over resistance through the 3 ohm resistor, of course, is 3 ohm, plus resistance through the 6 ohm resistor is 6 ohm. So 1 over 3 plus 1 over 6, you'll simply get a total of 1 over 2. So if 1 over R through the 3 and 6 is equals to 1 over 2, if I take reciprocals on both sides, I'll simply have resistance through the 3 and 6 ohm resistor being equal to 2 ohm. That is the reciprocal of a half. You'll get 2 ohm. Now the 2 ohm represents a combination of 3 and 6 ohm resistor. So that means our circuit simple will disintegrate into So it will disintegrate into this, such that we have combined 3 and 6 ohm resistor, which have given us the 2 ohm resistor. So the combination of 3 and 6 is actually the 2 ohm resistor. Then from here we can as well combine the 2 ohm resistor and the 13 ohm resistor, because remember the source of current was from here, so the positive terminal, the current flows up to this junction, and at this junction it is divided into two. So one current flows through 5 ohm resistor, the rest of the current flows through the 13 and the 2 ohm resistor. So again, because the same current flows through the 13 and the 2 ohm resistor, will combine the 13 and the 2 ohm resistor first, but we cannot combine the 2 and the 5 ohm resistor because different currents flows through 5 ohm resistor and the 13 and 2 ohm resistor. But the same current flows through the 13 ohm resistor and the 2 ohm resistor, because the 13 and the 2 ohm resistor, they belong to the same side of this particular junction here. So if you look keenly at the 13 ohm resistor and 2 ohm resistor, they are connected along each other. Therefore, they are in series with each other. Then we said for any series connection, R total is equals to R1 plus R2. So the current through the 13 ohm resistor and the 2 ohm, no, the resistance through the 13 ohm resistor and the 2 ohm resistor will simply take R through the 13 ohm resistor plus R through the 2 ohm resistor, which gives us R through the 13 ohm resistor, of course, is 13 ohm, plus R through the 2 ohm resistor, of course, is 2 ohm. So 13 plus 2, you'll simply get a total of 15 ohm. So that is the resistance that flows through the 13, and that is the resistance through the 13, a combination of 13 and the 2 ohm resistor. So now it means the 13 and the 2 ohm resistor combined, they are giving us a resistance of 15 ohm resistor. So clearly you can see that the 5 ohm resistor and the 15 ohm resistor are in parallel with each other. So if you have two resistors in such a way that the current flowing through is actually different, it simply means that the resistors are in parallel with each other. Because if the current is different, it means I total is equals to I1 plus I2. However, if the current was the same, then it means I total is supposed to be equal to I1 must also be equal to I2. So because different currents flows through the 5 ohm resistor and also a different current flows through the 15 ohm resistor, it means that because the current through the 15 and the 2 ohm resistor are different, it means we are talking of parallel connection. Therefore, the 5 ohm resistor and the 15 ohm resistor are in parallel connection. Remember, our aim was to find the current through the 13 ohm resistor, and remember 13 ohm resistor has been combined into, that is the 13 and the 2 ohm resistor, they have given us the 15 ohm resistor. So the easier way of getting the current through the 13 ohm resistor is by first of all finding the current through the combination, that is through the 15 ohm resistor. Again, you can see the 15 ohm resistor, 5 ohm resistor, and the battery or our source of current are actually in parallel connection. And we said that for any parallel connection, V total must be equal to V1, must also be equal to V2. So that simply means that the voltage through the 6 ohm resistor is equal to the voltage through the 5 ohm resistor is also equal to the voltage through the 15 ohm resistor. That's why you are saying that V total, which is the 6 volts, is equal to the voltage through the 5 ohm resistor is equal to the voltage through the 15 ohm resistor. The reason being the cell, that is the battery, the 5 ohm resistor and the 15 ohm resistor are actually in parallel connection. And we said that for parallel connection, V total is equal to V1 is equal to V2. Therefore, the voltage through the 5 ohm resistor is equal to voltage through the 15 ohm resistor is equal to V total. So remember, V total we are given as 6 volts. That is from the question. Therefore, the voltage through the 15 ohm resistor is simply 6 volts. Then from there, our aim is to find the current through the 13 ohm resistor. And we know that the 13 ohm resistor has been combined to give us the 15 ohm resistor. So we'll first of all find the current through the 15 ohm resistor so that it helps us to find the current through the 13 ohm resistor. So from Ohm's law, we know that V is equals to IR. So if we want the current through the 15 ohm resistor, we must have the voltage through the 15 ohm resistor and the resistance through the 15 ohm resistor. But because you already have the voltage through the 15 ohm resistor, so it means now our work will be easier. So of course, if I make current subject of the formula, I'll just divide both sides by R, so that current is equals to V over R. So that means the current through the 15 ohm resistor will be equal to the voltage through the 15 ohm resistor over resistance through the 15 ohm resistor, which is equals to the voltage through the 15 ohm resistor. We have already said that it will be equal to the supply voltage, because the 15 and the 5 ohm resistor are actually in parallel connection with our battery. So that means the current through the 15 ohm resistor is V, that is voltage through 15 over resistance through the 15 ohm resistor. So because the voltage through the 15 ohm resistor is 6 volts, it means if I substitute the values, I'll have V through the 15 ohm resistor being 6 divided by resistance through the 15 ohm resistor, of course, is 15 ohm. Therefore, 6 divided by 15, I'll simply get 0.4 amperes. So this is the current that is flowing through the 15 ohm resistor. But remember that for us to obtain the 15 ohm resistor, we were adding the 13 ohm resistor and the 2 ohm resistor. So this one simply means that the current that is entering through the junction, this particular junction here, to flow to this side of 13 and 5 and 2 ohm resistor, is actually the current through the 15 ohm resistor. Because remember, 15 ohm resistor is the combination of 13 and 2. So the current flowing through this part or through this side of the junction is simply the current through the 15 ohm resistor, because 15 is obtained by adding 13 and 2 ohm resistor. Therefore, and remember, the 13 ohm resistor and the 2 ohm resistor are actually in series connection, and we say that for series connection, I total is equals to I1 is equals to I2. So that simply means the current that is entering this junction, which is the current through the 15 ohm resistor, is equal to the current through the 13 ohm resistor, and is also equal to the current through the 2 ohm resistor, simply because they are in series connection. They are in series connection. So the current through the 13 ohm resistor is equals to the current through the is equals to the current through the 2 ohm resistor, this particular 2 ohm resistor, which is equals to the current through the 15 ohm resistor, that is the combination of 13 and 2, which is simply equal to 0.4 amperes. So the reason being that the 13 ohm resistor and the 2 ohm resistor were in series connection. And we know that for series connection, the current that is entering a junction must be equal to the current through each component. And the current that is entering the junction of 13 and 2 is actually the current through the 15 ohm resistor, because the 15 ohm resistor is a combination of 13 and 2. So you can see we added 13 and 2 to give us the 15 ohm resistor. So because they are in series, the current flowing through 15 ohm must be equal to the current through the 13 ohm must be equal to the current through the 2 ohm resistor, which is equals to 0.4 amperes. Reason being they are in series connection. Then part B, they want us to find the total current in the circuit. Remember, to find the total current from Ohm's law, V is equals to IR, we must have the total voltage and also the total resistance. So to find V total, that is the total current, we'll simply take V total is equals to I total times total resistance through the circuit. So we already have the total voltage through the circuit, which is 6 volts, but we don't have the total resistance through the circuit. So that is R effective. So we've broken our circuit up to this particular point. So we can easily find the total resistance through the circuit, that is R effective. You can see that the 5 ohm resistor and the 15 ohm resistor are actually in parallel connection. And you have said that for any parallel connection, R total, that is R effective, is 1 over RT is equals to 1 over R1 plus 1 over R2. Therefore, if I want to find the effective resistance through the whole circuit, I'll simply take 1 over R total must be equal to 1 over resistance through the 5 ohm resistor plus 1 over resistance through the 15 ohm resistor, which is equals to 1 over 5 plus 1 over 15, which gives us 4 over 15. So that means 1 over R total, 1 over R total or effective is equals to 4 over 15. If I take reciprocals on both sides, I'll have R total being equal to, the reciprocal of 4 over 15 is just 15 over 4. On simplification, we'll simply get 3.75 ohms. So that is the total resistance or the effective resistance through the whole circuit. Now, because we have the total voltage and we now have the total resistance, we can easily find the total current through the circuit, which was what we were asked here. So from Ohm's law, V is equals to IR. If I want current, I'll simply divide both sides by R so that I have current being equal to V over R. So the current, the total current, I total is equals to total voltage through the circuit divided by the total resistance or the effective resistance. Total voltage through the circuit was 6 volts, which is 6 over total resistance through the circuit was actually 3.75. We've just computed it here, 3.75 ohms. So 6 over 3.75, you'll get a total current of 1.6 amperes. So that is the total current in the circuit is actually 1.6 amperes. Then part C, they want us to find the voltage across the voltage through AB and also the voltage between points B and D. So let's start with the voltage across point A to B. So you can see from the diagram, point AB, between A and B, actually we have the 13 ohm resistor. So in short, the voltage between point A and B is just the voltage through the 13 ohm resistor, because between point A and B we have the 13 ohm resistor only. So the voltage through point AB is equal to the voltage through the 13 ohm resistor, which is just equal to, remember we already have from the Ohm's law, voltage is current times resistance. So we already have that is that will be the voltage through 13, which is V. The voltage through A and B is just the current, the product of the current through the 13 ohm resistor and the resistance through the 13 ohm resistor. That is from Ohm's law, IR. We already have the current through the 13 ohm resistor. We had already computed it at this particular point. The current through the 13 ohm resistor was simply equal to 0.4 amperes. So it is 0.4 times the resistance through the 13 ohm resistor is simply 13 ohm. So 0.4 times 13 will get a voltage between point A and B being 5.2 volts. Then the voltage through point B and D. So remember that the voltage through point B and D, so we can see between point B and D we have the 3 ohm resistor. So if we want to find the voltage through point B and D, it's just the same as saying the voltage through the 3 ohm resistor. So the voltage between point B and D is equal to the voltage through the 3 ohm resistor. But remember at this particular point, 3 ohm resistor is in parallel connection with the 6 ohm resistor. And we know that for parallel connection, V total is equals to V1 is equals to V2. So that simply means the voltage through the 3 ohm resistor is equals to the voltage through the 6 ohm resistor. The reason being the 3 and 6 ohm resistor are in parallel connection. So voltage through BD is equals to voltage through the 3 ohm resistor is equals to the voltage through the 6 ohm resistor, which is equals to the voltage through the 2 ohm resistor. So why is it equal to voltage through the 2 ohm resistor? Because remember, the 2 ohm resistor was actually the combination of 6 and 3. Remember here, when we combined the 3 and the 6 ohm resistor, it gave us an effective or a total resistance of 2 ohms. So actually the 2 ohm resistor is the combination of 3 and 6 ohm resistor. And because 3 and 6 ohm resistor were in parallel connection, that is initially, we know that for any parallel connection, V total, the current, the voltage entering a junction must be equal to the voltage drop across each component. So the voltage between that is entering this junction, that is, suppose the voltage was flowing this way. The voltage that is entering this junction at point B is actually the voltage through the combination of 3 and 6, which is actually the voltage through the 2 ohm resistor. So because the voltage through the 2 ohm resistor, the 2 ohm resistor represents a combination of 3 and 6, and therefore the voltage entering the junction of 3 and 6 volts, that is 6 ohm, is just the voltage through the 2 ohm resistor, because 2 ohm resistor is a combination of 3 and 6. So the voltage through the 3 ohm resistor is equals to voltage through the 6 ohm resistor is equals to the voltage through the 2 ohm resistor. The reason being 2 and 6 ohm resistor, that is 3 and 6 ohm resistor, were in parallel connection. So for parallel connection, we know that V total is equals to V1 is equals to V2. So because you already have the current through the 2 ohm resistor from this working here, it will be easier for us to use the values of 2 ohm resistor in order to find our voltage. So again, we know that voltage is equals to current times resistance, that is IR. So the current through the 2 ohm resistor, we had already computed it here. The current through the 2 ohm resistor was 0.4 amperes times resistance through the 2 ohm resistor is actually 2 ohm. So I times R, the current through the 2 ohm is 0.4 amperes. That is from here, I through the 2 ohm was 0.4 amperes, times the resistance through the 2 ohm resistor, of course, is 2 ohms. So this will give us 0.4 times 2. We'll simply get total voltage through point B and D as being 0.8 volts. Next, let's look at our second example, which reads that the figure below shows a current of 0.8 amperes passing through an arrangement of 4 resistors. So find the current through the 10 ohm resistor. So to find the current through the 10 ohm resistor, we'll start by finding the total or the effective resistance. So for this particular case, we said that we follow the route or the direction of the current. So you can see that the current is emanating from the left hand side. So when it gets to this junction, it is divided. So there is one current that flows through the upper route, while the other current flows through the lower routes. So we shall combine resistors that have the same current. For example, let's start by the resistors which have the current which is flowing through the upper route. So at this point, current is divided into two. So one flows through the lower route, while the other current flows through the upper route. So because the same current flows through the 30 ohm resistor and the 10 ohm resistor, we'll first of all combine those resistors. So the 30 ohm resistor and the 10 ohm resistor are connected along each other, therefore they are in series connection. So for series connection, we know that R total is equals to R1 plus R2. Therefore, the resistance through the 30 ohm resistor and the 10 ohm resistor is just equals to resistance through the 30 plus the resistance through the 10 ohm resistor, which is equals to 30 ohm plus 10 ohm, which gives us a total of 40 ohm. Then after that, we'll also combine the resistors, that is the 20 ohm resistor and the 40 ohm resistor, and I'm combining the 20 and 40 because when the current emanates from this point, at this particular junction, the other current flows through the 20 and the 40. So you combine the resistors in such a way that those that are having the same current flowing through it, they are always combined together. So like for this case, one current flows through the upper route, that is through the 10 and 3 and 30. That's why I've combined 30 and 10 ohm resistor, while the other current flows through the 20 ohm resistor and the 40 ohm resistor. Therefore, I'll combine the 20 and 40 because the same current flows through them. So you can see the 20 ohm resistor and the 40 ohm resistor are actually in connected along each other, therefore they are in series connection. So for series connection, R total is equals to R1 plus R2. Therefore, R through the 20 and 40 ohm resistor is equals to R through the 20 plus R through the 40 ohm resistor, which is equals to 20 ohm plus 40 ohm, which gives us a total of 60 ohm. Now, we are ending up with a combination of 30 and 10 has given us 40 ohm resistor. Then a combination of 20 ohm and 40 ohm has given us a total of 60 ohm resistor. Now remember, at this particular junction, the current is divided. So a different amount of current flows through the upper route, while the other current flows through the lower route. So if different current is flowing through any resistors, it means that they are in parallel connection, because we know that it is only for parallel connection where the current is divided. Otherwise, if it was series connection, we expect I total to be through to be the same as I1 to be the same as I2. But because here the current is divided, it means different current flows through the 40 ohm resistor and different current flows through the combined 60 ohm resistor. So because we are talking of different current, it means that the 40 ohm resistor and the 60 ohm resistor are actually in parallel with each other. So for parallel connection, we know that V total is equals to V1 is equals to V2. Then I total will be divided. That is I1 and I2 are different. So that is what we mean by parallel connection. So what we shall do, remember the aim is to find the current through the 10 ohm resistor. And now the 10 ohm resistor is in between the 40 ohm resistor, because we combine the 30 and the 10 in order to find the 40 ohm resistor. So what we are going to do, we'll first of all find the current through the 40 ohm resistor. So that current will help us to find the that is the current through the 10 ohm resistor. So the first thing, let me just complete this particular circuit. So because the current is coming from this particular point, and we know that the current will always flow from the positive terminal of the battery, it means if we complete the circuit, this is how the circuit was supposed to be. So the battery is on this side because the current, the initial current is flowing towards the right hand side. So it is coming from the positive terminal of the battery, flowing in that particular manner. So you can clearly see that we have the total current. So in order to find the total voltage, so that we shall say that the source voltage is equal to voltage through 40 and 60, we need the total resistance. So we know that V is equal to IR. So if we want the total voltage, we must have the total current and the total resistance. But from the question, we are already given the total current. So our aim is to find the total resistance, so that it can help us to find the total current through the total voltage through the battery. So up to this point, so the 40 ohm resistor and the 60 ohm resistor are actually in parallel, and we know that for parallel connection, 1 over R total is equals to 1 over R1 plus 1 over R2. So R effective, 1 over R effective is equals to 1 over R through 40 and 60. That is this combination because they are in parallel. So that is 1 over 40 plus 1 over 60, which gives us 1 over 24. So if 1 over R effective is equals to 1 over 24, if I take reciprocals on both sides, or if you cross multiply, you will end up with effective resistance being equal to 24 ohm. Now, because we have the effective resistance or the total resistance through the circuit, and we also have the total current through the circuit, we can easily find the total voltage through the circuit. So from Ohm's law, V was equals to IR. So V total will be equal to total current times total resistance. So total current through the circuit we were given as 0.8 amperes, because we are told that a 0.8 ampere passes through the arrangement. So that simply means that that is the total current through the circuit. So total voltage will be total current, which is 0.8 times effective resistance, which we have computed as 24 ohm. So the total current, the total voltage flowing through the source is actually 19.2 volts. That is 0.8 times 24. Now, once we have the total voltage or the effective voltage, we can easily find the current through the 10 ohm resistor. Now remember, the 40 ohm resistor and the 60 ohm resistor are in parallel connection with the battery or the source. And we know that for parallel connection, V total must be equal to V1 must be equal to V2. So that simply means the voltage through the 40 ohm resistor is equals to the total voltage through the source, because the 40 ohm resistor, the 60 ohm resistor, and the source are actually connected across each other, or they are in parallel connection. And for parallel connection, V total is equals to V1 is equals to V2. So the voltage through the 40 ohm resistor is equals to V total, which was actually equal to 19.2 volts. So because we have the voltage through the 40 ohm resistor and we have the resistance through the 40 ohm resistor, we can easily find the current through the 40 ohm resistor. And remember, the 40 ohm resistor was a combination of 30 and 10. And remember, 30 and 10 were actually in series connection. And we know that for any series connection, the voltage, the current entering that junction must be equal to the current through each component. So for series connection, I total is equals to I1 is equals to I2. So because the combination of 30 and 10 gave us 40, it means that the current through the 40 ohm resistor must be equal to the current through the 30 ohm resistor and the current through the 10 ohm resistor. The reason being the 30 and the 10 ohm resistor were in series connection, or they were connected along each other. So the current through the 10 ohm resistor is equal to the current through the 40 ohm resistor, which is a combination of 30 and 10, which were in series. And we know the current through the 40 ohm resistor will simply take from V is equals to IR. Current will be voltage over resistance. Therefore, the current through 40 ohm resistor will be voltage through 40 over resistance through 40 ohm resistor, which is just equal to voltage through 40 ohm resistor was equals to V total, because they were connected in parallel with the battery, which is equals to 19.2 volts divided by resistance through the 40 ohm resistor is just 40 ohm. So 19.2 divided by 40, you will get the current through the 10 ohm resistor, which is equals to the current through the 40 ohm resistor being equal to 0.48 amperes. Then I have an exercise here that I do recommend you should try to gauge your understanding. So we've come to the end of our class today, but we need to discuss the quote of the day. The quote of the day stated that there are two ways of spreading light. One is to be the candle that produces light, and two is to be the mirror that reflects the light to others. So the quote is encouraging us to be human beings who are willing to create an environment for others to grow and achieve their dreams. It is also warning us against being obstacles for other people's growth. And recall that no act of kindness goes without a reward. Therefore, keep celebrating other people's success, because your success, that is, your success is also on the way coming. So be happy for other people's success, and your time will also come for you to celebrate your own success. And lastly, remember that if you can't improve someone's situation, at least refer them to someone who can help them. But don't leave their situations worse than you got it. Thank you very much for accompanying me until the end of this particular lesson. I do not take it for granted. In case you are new to the channel, kindly hit the subscription button and also turn on the notification bell so that whenever I upload a new video, you'll get notified. This is Kind Tuition Academy. Until next time.